Hello, this is for Exponents and Factoring. I wanted to take you through the rules of operating on exponents one more time. If you look at our first example, we have x squared times x to the third. That's like me saying multiply x twice times, and then multiply x 3 times. And so how many times have we multiplied x by? We multiplied by itself 5 times. A quick way to do that is just to add the exponents 2 and 3. If you don't see an exponent, on the next example, there's a 1, so that would actually be 3 to the 5th. And if there's multiple variables and constant terms, for example, we would multiply 2 and 3 and get 6. For x, we could just add the exponents and get 7, and for y, we could just add the exponents and get 9. If you see parentheses and you're taking a power to another power, you are going to multiply those. It's kind of like me saying take x squared times itself 3 times. 2 plus 2 plus 2 is 6. And so again, a quick way to do that is just to multiply the 2 times 3. So on top, in the numerator, I would have 3 to the 20th power. But when I distribute the 5 into the parentheses, it would be x to the first to the 5th. So just x to the 5th. On example 3, x to the third and y to the third. Since x and y are both in the parentheses, I'll distribute the 3. So x to the third, but y already has a 4, so we're going to multiply those and get 12. Last example, 2 to the third power, x to the 15, y to the third. On the bottom, we would have z to the 12th, since we'll multiply the 4 and 3. Remember, negative exponents tell you to do the reciprocal. So normally 5 to the second would be 25, but I want you to do the reciprocal, so 1 over 25. X to the first, do the reciprocal, so 1 over x to the first. If you see that negative exponent and it's already in the denominator, we just want to flip it up top. Now I want you to notice 3 just stayed 3. Nothing happened to it. It didn't have a negative exponent. There was no reason to move it anywhere. A 0 exponent equals 1. So that's just 1. That's just 1. Now order of operations would tell me to work with the exponents first. So x to the 0 is 1. But I'm still going to multiply by 3. So 3 times 1 is 3. When we divide, we're canceling out, and we can just really subtract the exponents. So 3 to the second. But this time when I subtract, I get x to the negative 2. So that'll be really x squared. Think about canceling out 5 x's. There's 5 x's on top, but there's 7 on the bottom. So if we cancel all 5 on top and 5 of those on the bottom, we're left with 2 on the bottom. You can think about it that way as well. The last one, 5 just stays 5. Sorry.
Nathan Weber, please come to the guidance office. Nathan Weber, please come to the guidance office.
Again, either you can take 2 minus 5, and x to the third would be on the bottom. You can cancel out 2 of the x's, and you'd be left with x to the third. Factoring we've just been through, but just want to remind you of a few things, just like factoring out the GCF first. So I can factor out 3 and an x, and I'll get 3x minus 2 left over. That's how we can factor out GCF. It's like backwards of distributive property. On this next one, I see that I could factor out a 4 and an x to the fourth. If I factor out a 4, I'll get 4x to the second minus 1. Now technically that can be factored a little bit further, but we'll deal with that later. I just wanted to show you the GCF first. Remember dots, difference of 2 squares. This is when you only have a binomial, so there's 2 terms. When you factor it, we factor out x and x, and then 25 is factorable with 5 times 5. We have plus and minus. The negative tells us that the signs are different, so we'd have a positive and a negative. When you check your smiles, we would have negative 5x plus 5x. That would give us that 0 term in the middle. Same thing happens on the next one. We'd have 2x plus 3 and 2x minus 3. The 4 gets split up as well as the 9. The trinomial is always everybody's favorite. You multiply x and x, and you say what times what is 6, that adds up to 5. And then you get 2 and 3. You can certainly check your smiles there as well. And the last one, we have x and 2, x and 3. We have to decide the signs are different. There's a negative sign in the middle, so the bigger number gets the negative sign. I just want you to see a few things on the next page. This number 6 is pretty difficult. If you look at all three of the terms, there's a 4, 4, and an 8. Think about reducing fractions. All of those can be divided by 4. So now there's a 1, a 2, and a 1. And the other thing that all of these can be divided by is x. So 1, and then the x goes away. One of these x's go away, so there's just an x there, and that x goes away. That's pretty difficult. 1 over 2x plus 1. We'll certainly do another one of those in class. The other ones that I wanted you to see, like on number 9, where you have to find the zeros. It's pretty easy to find zeros from a graph. You have negative 2 and 1. Those are your x-intercepts. But if you have an equation and they ask you to find zeros, what you're going to do is set it equal to 0 and then factor and solve. So I have a GCF, and I get x plus 4. Remember at the very end to tell me what x equals. I'm trying to get 0, so right here I could plug in negative 4, and that would give me 0. And then right here, I could just plug in 0 right there in front and multiply it and get 0. There's another one. What times what is 18? 9 and 2. The signs are different. There's a negative in the middle, so the bigger number gets the negative sign. Let's just solve it. I'm trying to get 0, so what can I plug in? 9 and negative 2. Just remember, like number 10, I'll just get you started. It has to equal 0, so I'm going to bring over the negative 20 by adding it to the other side. And then you can go ahead and finish it. And that's it. Have a good day.